Have you heard? The potential for a universal flu vaccine. The threat of a pandemic or epidemic of influenza, particularly from a mutated avian influenza virus, still looms large for people as well as for dogs and cats. People and cats have already become infected and died of a form of the avian flu. A single vaccine that could be administered to birds, pets, and people to prevent influenza sounds like science fiction. But some researchers at the University of Maryland may have discovered the key to creating just such a wonder. The researchers took the central genes of the avian influenza virus H9N2, which is capable of infecting many different species, including poultry, mice, and pigs, and modified the genes to make the virus less virulent. They hypothesized that since this strain has such a broad host range, using an attenuated form as a backbone for vaccination may be effective without modification in many species as well. They first tested this H9N2 backbone in birds, and it successfully prevented illness. Their next step, as published in the November 2008 issue of the Journal of General Virology, was to use this same backbone in mice, which, if protective, would suggest efficacy in many species, including cats, dogs, and people. In this study, the researchers intranasally inoculated 5-week-old female mice with differing concentrations of one of two recombinant influenza viruses that also contained the attenuated H9N2 backbone. The viruses used were the H1N1, the culprit in the Spanish flu of 1918, and H5N1, a bird flu virus. After inoculation, the mice were monitored for 3 weeks, looking for any clinical signs of flu, changes in body weight, and death. 3 weeks after inoculation, the mice were challenged with the corresponding wild-type H1N1 or H5N1 virus intranasally. To evaluate each vaccine's effect on virus replication, the researchers also looked for virus titers through homogenized lung tissue obtained from 3 euthanized mice in each test group 3 to 6 days after challenge. The results? For both viruses, those mice receiving the genetically modified versions of the viruses and subsequently challenged with the corresponding wild-type virus did not develop clinical signs of flu, and they all survived. They were able to clear infection in 3 days in most cases. In contrast, all control mice died by 8 to 10 days after challenge. Mice that received the H1N1 attenuated vaccine had little evidence of virus in their lungs 3 days after challenge, in contrast to controls. But even though the mice that received the attenuated H5N1 vaccine were protected from clinical infection, a significant amount of virus was isolated from their lungs. The researchers decided to test whether a booster inoculation of the H5N1 attenuated virus 3 weeks after the first inoculation and subsequently challenged 3 weeks later would reduce virus replication. The mice that received the booster had much less virus in their lungs by 6 days after challenge. So the researchers concluded that a booster vaccine will lead to faster virus clearance. Another part of the study tested cross-protective immunity of the H9N2 backbone. Mice were immunized with a heterologous subtype virus, H7N2, and then challenged with one of the 2 wild-type viruses used in the H1N1 and H5N1 experiments. The mice had some weight loss after challenge, but all survived, suggesting that the H9N2 backbone provides cross-protective immunity against the 2 lethal virus challenges. In the case of the H5N1 challenge, the researchers again tried an attenuated H7N2 booster vaccine 3 weeks after inoculation in some mice, and then challenged with wild-type virus 3 weeks later. This time, significant virus titers were found in the lungs of the mice that received the H5N1 attenuated vaccine, regardless of whether they received a booster. So the booster did not stop virus replication in the lungs. The researchers surmised that the H9N2 backbone does protect mice from challenge, but doesn't necessarily stop virus replication early in the infection. Overall, the researchers concluded that the H9N2 backbone is attenuated in mice no matter what virus is present. The H9N2 backbone was as effective in preventing the flu in these mice as it was in birds in the previous study. The implications for this are great. If a vaccine is developed with this backbone for birds, the same vaccine can be used in mice and potentially in other mammals, including dogs, cats, and people, and we would be on our way to a universal influenza vaccine.